The Pearson correlation coefficient measures the strength and direction of the relationship between two continuous variables. It can take values in the -1, +1 range. -1 means a perfect negative correlation, 1 means a perfect positive correlation, and a value of 0 means no relationship between the variables. The Pearson correlation coefficient is noted with R. Most often, the researcher wants to assess the correlation in the total population, not just in the sample. So, he or she must run a test to determine whether this coefficient is different from 0 in the total population. The null and alternative hypotheses for this test are as follows. The null hypothesis. The correlation coefficient is equal to 0 in the total population. And the alternative hypothesis. The correlation coefficient is not equal to 0 in the total population. In this lesson, we are going to learn how to test this hypothesis. The size of the Pearson correlation coefficient indicates the strength of the association between the variables. The table you're seeing right now contains some rules for evaluating this strength. So, if the R is up to 0.30, we have a small or weak correlation between the variables. If the Pearson's correlation coefficient is between 0.30 and 0.70, we talk about a medium or moderate correlation. And if R is over 0.70, we talk about a strong correlation between our variables. On the other hand, the sign of the correlation coefficient reveals the direction of the association. Subsequently, if the coefficient is positive, we are dealing with a direct or positive correlation. So, when one of the variables increases, the other one tends to increase too. And if the coefficient is negative, we are dealing with an inverse or negative correlation. When one of the variables increases, the other one tends to decrease. We cannot use the Pearson correlation unless the following assumptions are valid. The two variables are continuous. The variable values are pairs, so there are two values, two measurements for each sample case. The relationship between the variables is approximately linear. That's the most important assumption of all. The Pearson correlation coefficient is sometimes called the linear correlation coefficient. The variables are approximately normally distributed, and there are no significant outliers among the data. That being said, we can move to our practical example. Let's go to the Insure-SAV database. As you remember, this database contains information about 70 customers of an American insurance company. We are going to find out whether there is a significant correlation between the weight and the height of our subjects in the total population. So, the variables of interest are CAS-WGT, the subject weight, and CAS-HGT, the subject height. They are continuous variables and their values are pairs. For each case, we have measured the height and the weight. So, the first two assumptions for the Pearson correlation are met. In the next video lesson, we are going to test the other three assumptions.